Coming to the operation, coming to the start operation of this frequency meter. So now we want to start the measurement of the frequency. So what we will do? We will give this read pulse to the SR flip flop of reset pin of the SR flip flop now. So it will reset the SR flip flop to 0 level. So making the Y 0 and Y bar 1. So this reset of the SR flip flop changes the output state. So now the Y becomes 0 and Y bar becomes 1, making the start gate enable and stop gate disable. Okay. So we know that the pulses are continuously coming from this time-based selector, which is given to the point B of this start and stop gate. Okay. But because this stop gate is disabled, this pulse will not pass through this stop gate, but start gate is enabled now. So the pulse from the time-based selector will pass through this gate and it is given to the reset pin of the flip-flop 2. Okay, reset pin of the flip-flop 2, making this reset and which changes the output state. So now Y becomes 0 and Y bar becomes 1. So which will enable this main gate and the train of pulses from the input will enter the counter. Is that understood up to this point?
Sir, screen is not visible, sir.
Okay. Should I have said that earlier? No? Okay, anyway. Okay, is it visible now?
Yes, sir.
Yes, sir.
Okay, I will restart once.
Yes, sir.
Okay. When we start to measure this frequency of the unknown signal, we will give this read pulse to the reset pin of the SR flip flop, making it 0. Okay. So this reset of the SR flip flop 1 will change the output state of this SR flip flop. Now Y becomes 0 and Y bar becomes 1, making the start gate enable and stop gate disable. So this is enable now and this is disabled. Stop gate is disabled. So we know that pulses are continuously coming out of this time-based selector, which are given to this point B of this both gates. But stop gate is disabled, so the pulse will not pass through this. But the start gate is enabled, so the pulse from the time-based selector will pass through this gate, and it is given as input to the reset pin of the SR flip flop 2. So making it a 0 state. So that's why the Y output becomes 0 and Y bar output of this SR flip flop becomes 1, making this main gate enabled. So now the main gate is enabled and the train of pulses from this Schmitt trigger, which is having the train of pulses of the input signal, the input unknown signal, is given to this counter. Okay, have you understood up to this point? So now the counter starts counting. Now the counter starts counting these train of pulses. How many train of pulses? How many pulses are receiving? Okay. But we need to stop this for exactly how much time? For exactly 1 second. So we need to enable this main gate for exactly 1 second. So this pulse duration from this time-based selector should be of 1 second duration. So this pulse generated by this time-based selector should be of 1 second duration. So that kind of pulses are emitted continuously by time. It is also given to the set pin of the SR flip flop 1. At the same time, it is also given to the set pin of the SR flip flop 1. So this set pin will make this SR flip-flop 1 set, which will change the output condition of this flip-flop. Now Y bar becomes 0 and Y becomes set 1. Okay. Now again, the stop gate is enabled and start gate is disabled. Start gate is disabled and stop gate is enabled. So now with the enable of this stop gate, the next clock pulse, the next pulse from this time based selector will pass through the stop gate, not from the start gate. Because start gate is disabled and stop gate is enabled, the next pulse from the time based selector will pass through this stop gate, which will enter and given to this set pin of the SR flip-flop 2. Flip-flop 2 becomes 1, making Y 1 and Y bar 0. So now it will display. Is that understood? Am I audible?
Yes, sir.
Yes, sir. Yes.
Okay. Have you understood the working of this measurement of frequency block diagram?
Yes, sir.
Yes, sir.
Yes, sir.
So any doubts in this block diagram? Any doubts?
No, sir. No, sir.
So it's a simple one and it can be asked for 8 to 10 marks. The basic circuit for frequency measurement using the gate control flip-flop. So this part, so this part of this circuit, we call it as a gate control flip-flop. So the signal that we are getting out of this gate control flip-flop will enable or disable the main gate. So we call this signal as a gating signal. So we call that as a gating signal. And this signal from the input signal whose frequency we are trying to measure, this signal we call it as a counter signal. Okay, because this is given to the counter for the measurement, we call it as a counter signal. And this signal we call it as a gating signal. And one more thing, we should take care that the pulses that are coming out of this time-based selector should be of 1 second duration. Then only we can easily convert this counted value to the frequency. Okay, because whatever the train of pulses, whatever the number of pulses counted by this counter during this second is directly related to the frequency of the signal. Okay, is that understood? Any doubts on this?
No, sir.
Okay. What about others? Any doubts?
No, sir.
Yes, sir.
No, sir.
Okay. How many students from B division here? Raise your hands. How many students are from B division? Okay, any doubts? No? So then we will wind up this class here only. In the next class, we will discuss about the digital measurement of time. How we are going to measure the time. So today we have discussed about the measurement of frequency using the block diagram. We have seen two circuits actually. One is the basic circuit for the showing the basic operations required for the measurement of the frequency, and other one is the detailed block diagram, which is having the gate control circuit. Okay. So if in exams they ask for 8 to 10 marks, so you need to draw both of them. Okay, explaining both of them. So 1 to 2 page of explanation will be enough for this 10 marks question. Okay. If they ask for 10 marks, you need to draw both circuits. Is that understood?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Okay.
Yes, sir.
So we will end the class now. Thanks for joining.